This one looks to be a little bit longer here. And as a teacher at an elementary school, she purchased 72 tickets to take the first grade children and some parents on a field trip. We've got $10 tickets and $18 tickets. We are not mixing together liquids, but we're mixing together two different types of tickets at different prices. So let me put our little design up at the top here. I'm still going to use mixing bowls, even though that doesn't seem the right apparatus for what we're doing here. She's purchasing 72 tickets. That's all together. That's over here on the right, and that's the amount, the number of tickets. The children's tickets are $10 each, so I'm going to put a 10 on the top, maybe a dollar sign there too, and those are child, so I'll put a C down below. And the adult tickets are $18 each, so I'm going to put $18 there, and there's A for adult. And she spent a total of $856, and that total is going to go up on the top right. Now, I want to make a point that that is a total, because when that is the case, we're going to do these problems a little bit differently. I'd also like you to notice that 856 does not fall between the 10 and the 18. If you go back to the previous two problems, which I'm going to do with you right now, notice how 8 falls between 10 and 5 on the first problem we did, and if we go down to the next problem, notice how 60 fell between the 75 and the 25. In this case, that 856 does not fall between the other two. It is a grand total. When we go to write our equation, we're actually going to get equations, two of them, because there's two variables. The first one's going to be top times bottom, 10a, plus top times bottom, 18, that should be 10c, sorry, 10c plus 18a equals 856. Well, that's got two variables in it. We need a second equation, and that's going to be across the bottom here. The number of child tickets plus the number of adult tickets adds up to 72. Child plus adult equals 72. So now we have two equations with two variables. This is known as a system of equations, which we're going to solve. Now what I'm going to do is use something called the substitution method. I'm going to take this first equation and rewrite it as C equals 72 minus A. That's what I get when I subtract off the A on each side. Then I'm going to take this C equals and substitute it into the first equation. Instead of 10C, this will become 10 times 72 minus A, and that's what C really is. Then plus the 18A equals 856. Okay, so now I have one equation. Notice there's only one variable in it because we've substituted out C for the 72 minus A. Now we're going to do some distribution and finish solving this equation. We're going to have 720 minus 10A plus 18A equals 856. We're then going to combine like terms on the left side of the equation. That will give us 720 plus 8A equals 856. I will then subtract 720 on each side of the equation. We will now have 8A equals 136. And dividing each side by 8 gives us A equals 17. That means 17 of the adult tickets. But we need to know how many of the children's tickets, and we know right up here that we can find C by subtracting the 17 away from 72. So 72 minus 17 gives us 55. 17 adult tickets, 55 child tickets. Okay, now this problem was quite different. First off, we weren't mixing liquids. We were mixing adult tickets and child tickets, each with different prices. And the second thing was this grand total up on the top right. When you have a grand total, instead of going top-bottom plus top-bottom equals top-bottom, you're going to stop up there with that top and not go top times bottom. So that was a slight difference compared with the other problems we were doing.